linear approximations. So in some textbooks, this is a very, very complicated section that AP Calc students hate. All right, it is not that complicated, so I'm going to make this as easy as possible. Do you all remember how to find the equation of a tangent line?
Yes.
Yeah, so you find the slope at a point, so you get your m, and then you have your x1, y1, right? And then you create a tangent line. Easy enough? That's what we're going to do over and over and over in this section. So I'm not going to give the complicated formula that's in the book, so you can look it up if you want to and use it if you want to. I'm just going to show you this like method, okay? So it says if you zoom in on a particular curve several times, the curve starts to look like a line. Okay, so have you guys ever done that on your calculator where you like zoom in, zoom in, zoom in, and then all of a sudden it looks like a straight line, but it's really part of a curve? So imagine if I zoom in on this area right here. Do you guys see how those look almost exactly the same? Right, so one is the curve, guys, and one is the tangent line, okay? So if I use a point that I can take the cube root of, so this is the cube root curve, you know how to take the cube root of 8, right? It's 2. Then I can use that to approximate things like the cube root of 8.01, okay? And it will be very, very precise. So instead of using the curve, like I don't know how to do the cube root of 8.01, well, I do know how to do that one, but 8.23. Like, who knows how to do the cube root of 8.23 without a calculator, right? A lot of guess and check.
I may be good at this.
So what we do is we use tangent lines to approximate it. So if you've ever seen, like, pre-calculator days, have you guys ever seen, like, the log tables and the natural log tables? Have you seen those? Remember in Algebra 2 I showed you a log table and you guys didn't like it? Little tiny numbers. Well, when I was in school, I know I did not go to school before there were calculators, but they wouldn't let us use calculators in class. And we had charts for like sine, cosine, and tangent as well. Okay, so there's like all these charts, and how do we create the charts? We create the charts using calculus. Okay, so let's do some examples, and this will make more sense. Okay, so number 1 says find the tangent line approximation of f of x equals 1 plus sine of x at the point 0, 1. Okay, use this tangent line to approximate f of 0.23. So before I even start, think about what f of 0.23 is. It would be plugging in 0.23 into 1 plus sine of x. Does anybody know how to find sine of 0.23 in their head?
No. I don't think it's possible.
There actually is something later on in Calc 2 that allows you to find things like that. With factorials, can you believe that? Don't you love factorials? Crazy. How math is all intertwined. Love it. All right, so we don't want to find that by hand, right? Don't know how to do this. How do we do this? We don't know. So we're going to use an approximation. Okay, so we're going to find f prime of x, which is going to be 0 plus the derivative of sine is cosine of x, and find our slope by plugging in a point that's close to 0.23. What x value is close to 0.23? 0. That's the one we're going to use. And that's what we said, use the point 0, 1. So f prime of 0 is cosine of 0, which is 1. That's our slope. And our point was 0, 1. So putting it together, we get y equals 1x plus 1. Right, that was our y-intercept, 0, 1. This is what we call the linear approximation. So in textbooks, you'll see L of x is approximately. So the linear approximation is 1x plus 1. So if we're trying to find f of 0.23, we say, well, it's approximately the same as the linear approximation of 0.23. Can we all do that in our head? 1 times 0.23 plus 1? Yep.
I don't know what that is.
I hope that you do know what that is. 1.23. Okay? So get your calculators out and go ahead and let's find the actual answer. So plug in 1 plus sine of 0.23. Oh, I guess I already did it in the last class. It's there. 1 plus sine of 0.23. What do we get when we plug in 0.23 for x? We get 1.227977524. Pretty darn close, right? If I was finding the error on that, it's pretty close, right? Do you guys remember how to find error like in science classes and so on? It's pretty close. All right, so let's look at the graph. So if I graph 1 plus sine of x, and I also graph, yeah, I'm in radians, and I graph 1 plus x, look what this graph looks like. Okay, I zoomed in, but let's do our standard zoom 6 so you can see what it first was. Whoops, I hit zoom 6.
1 plus x and 1 plus the sine of x.
Yeah, so 1 plus sine of x, we know what that looks like. It's the sine curve, it's just shifted up 1, right? Look at that line. Look how at the point 0, 1, so if I zoom in, you can see it. At this point, 0, 1, it's going to look like a line temporarily. So when I draw on that tangent line, do you guys see how they're almost identical right there? So if I continue to zoom in, have you guys ever used ZBox? That's like my favorite thing. I love ZoomBox. ZoomBox, basically you go like over to the corner of where you want a box to be created. So like right here. And you hit enter, and then you go over.
Stop showing it.
Because it just looks like a single line, right? So Ian's saying, when you continue to zoom in, it just kind of stops showing it.
To this.
Yeah, because it becomes like the same. So if I zoom in on that area, see how it's like almost the same thing. Okay, that's what we're doing. We're finding a linear approximation, a tangent line that looks so close to the curve when we zoom in, that we can use it to approximate.
Is it that if I zoomed in so far that it's not showing?
Well, your window's off now. All right, so part A of the next one. So find the linearization of the function f of x equals the square root of x at the point 4, 2. So whenever you see that, find the linearization of the function. What it's saying is find the equation of the tangent line at the point 4, 2. Can we all do that? Yeah. So we're going to do f prime of x is the square root of x is x to 1/2, so 1/2 x to the negative 1/2. Do you guys have it memorized what the square root of x, its derivative is? 1 over 2 root x, exactly. So our slope is going to be plugging in the x value that we said, so 4. So I get 1 over 2 square root of 4,
1/4.
which is 1/4.
Or negative 1/4, but do we just consider it positive for this?
What are you saying, negative 1/4? It's positive.
Negative 2 times negative 2 is 4. Square root of 1.
Oh, well, when you have a square root in the problem, it's automatically the positive version.
That's why.
Yeah. So I do y minus 2 equals m, which is 1/4, times x minus 4. And I distribute. So I get y minus 2 equals 1/4 x minus 1. So I get y equals 1/4 x plus 1. That is what we call the linear approximation, L of x. All right, so then the second part says, well, use this formula to approximate the square root of 3.98. So the square root of 3.98, think about back in the day before there were calculators. When calculus was first being invented, we didn't know how to find the square root of 3.98. We had to create these tables of square roots, right? So how did we create the tables? We used a linear approximation. So are you able to do that without a calculator? I know it makes you uncomfortable finding 1/4 of 3.98.
Oh, yeah.
But you could do that without a calculator. I did it in the last class. 3.98 divided by 4. I have 9 makes 36. 38 makes 36. If this is freaking you out as an AP Calc student, it makes me worried. If this is the hardest thing that you've ever done, I'm scared.
I think it should be 0.995.
So it's 0.995. So you could do that.
I already said it like 2 minutes ago.
All right. Anyway, so I'm going to have 1/4 of 3.98 plus 1, which ends up being 0.995 plus 1, so 1.995. All right, so then the square root of something else that's close, 4.05.
2.0125.
2.0125.
I know,
Ian
I
loves
use
this
my
stuff.
calculators.
I know, I'm impressed, Ian. You're good.
On academic, we know the calculators.
Pat on your back.
No.
All right.
That's a bad idea.
All right, so are these approximations over estimates or underestimates? So do you guys know how we find out if it's an over or an under? Yeah.
Isn't the square root of 3.98 equal to 1/4 times the square root?
Okay, no, I'm not actually finding the square root. I'm using the linear approximation. So here's what we did. So basically we have a curve, the square root function, right? And at a point, 4, 2, we're finding the equation of the tangent line. So we're saying when we zoom in on that tangent line, we can find something really, really close along the curve by using an approximation with that one that's like right there along the tangent line. Do you guys see how close those are? They're super close, right? So we just found along the tangent line. So we plugged into the 1/4 x plus 1, y equals 1/4 x plus 1, and we got a value. All right, is this value that I found, this approximation using the tangent line, is it above my actual curve or is it below my actual curve? The one that I found the approximation on this line. Is it above the curve or below the curve? It's above, right? Do we all see it's above?
Yeah.
So if the AP test ever asks you, is this an overestimate or an underestimate? Do you know what you do? You find the second derivative. Do you see how it's concave down? Do you remember the definition I gave you about concavity? I said anything that's concave down has all of the tangent lines above the curve, right? That's what you would do. Yeah, exactly. So when something's concave down, all of the tangent lines end up being above the curve. But if something's concave up, all of the tangent lines are below the curve. So if it ever says, is your linear approximation, is it an overestimate or underestimate, then you use the second derivative. Now in this case, we can just use the sketch, right? So this was an overestimate for both of them.
And actually, at this point, they would all be overestimates.
Alex. All right, so it says use this equation to approximate the square root of 25. Well, what if I used, we all know what the square root of 25 is, right? But what if I plugged it into the 1/4 of x plus 1? Yeah, square root of 25 should be 5, right? But if I plug it in, am I going to get something close to 5? I don't know. What's 1/4 of 25? 6.25.
Plus 1 is 7.25.
Is 7.25 really close to 5?
Congratulations.
That is not close to 5, is it? So why was this one so far off? Yeah, it's not close to it, right? We could use the math word. This is a math word. Neighborhood. In the neighborhood. So here's my 4,2. Yeah. Beautiful day in the neighborhood. All right, way over here. Way over here, we have 25. So this is going to continue to go kind of like that. But this one gets bigger and bigger and bigger, right? So something that's not close to that original point, the 4,2, is not going to be close. We're not going to use that to approximate, okay? Make sense? Yeah. Yeah, 4 is not close to 25.
No, but then it's the square root of 25. It's just
4 is closer to 25.
Okay, but we were talking about the x value. The x value is 25, right? 25 is what you're plugging into the square root function, not 5. All right, so number 3. So it says find the linearization of the cube root of x. Shh, guys, so if I have the cube root of x, well, I'm going to take the derivative again. Remember, the cube root of x is x to the 1/3. So it's 1/3 x to the negative 2/3. And it says at 64. So using my original function, what point am I at? 64 comma what?
4.
4. Do you guys see where Ian's getting that?
no.
No. Yeah.
Plug in 4 into the cube root of x,
Yeah.
or plug in 64, sorry, into the
it's
cube root
65
function.
minus 61, which would be 60.
No.
That's not
Also, 65 minus 61 is not 64.
All right, the cube root of 64, guys, be nice. The cube root of 64.
I was joking. Sure.
The cube root of 64 is 4. That's where we're getting it from. All right, so we're going to find our slope. So our slope is going to be g prime of 64, which is 1/3, 64 to the negative 2/3. So we're going to see how much you remember your algebra 2. This is what we're doing in algebra 2 right now.
That's true.
We are, because you're helping Fiona, aren't you? So it's 1 over, yeah, she just skipped. She's in algebra 2 as well, in AP Calc. All right, 64 under a cube root squared. And it was a negative power, so it's 1 over, right? So 1 over the cube root of 64 squared. Emily, you with me? All right, so we're going to do the cube root of 64, which is?
4.
So 4 squared is
Wow, your slope is really...
1 over 48. So we have 1 over 48.
That's a...
Yeah.
4 squared is not 48.
4 squared, sorry. 4 squared is 16. 16 times 3 is 48.
Extra point for the green.
And no, he doesn't get an extra point. I multiplied. We're good.
I mean, it's only you only extra points if you write it wrong. Right? If you just misspeak, then we don't.
Wow, Alex is really getting beat up today.
All right, so I have y minus y1 equals m times x minus x1. So this is going to create my linear equation, my linear approximation, right? So I'm going to distribute in. So I have 1 over 48 x minus 64 over 48. Ooh, 64 over 48, yes. Is divisible by 16 on the top and bottom. It goes to 4 over 3. So it's going to be 4 over 3. And then add the 4 over. Ian, give people a chance to think about it. Our little computer right here.
I thought my math was fast.
So I have negative 4 thirds plus 12 thirds. So negative 4 thirds plus 12 thirds.
I'm not the fastest person at this.
8 thirds. Nope, because it's negative 4. Negative 4 plus
Jay Maturity's faster
12
than
thirds.
this kind of stuff. Like,
Okay, good.
we call him 2 seconds.
I know, because he was trained for math counts.
Well,
I've known Jay for many, many years. All right, so this is our linear approximation. So you can write y equals, or you can write L of x. I don't care if you don't write L of x. Just know that that's your linear approximation, your tangent line approximation. So we're going to use this, and we're going to find the cube root of 65, and we're going to find the cube root of 61. Okay, Emily, are you with me? Just get the computer out, I can see it. I know it's hiding behind the bag. So sneaky. All right. So the cube root of 65. I know. Well, it's Rodrigo's main trick, so I see Rodrigo with that trick all the time. Only it's his phone. All right. Yeah. So the cube root of 65 is going to be approximately 1 over 48 times 65 plus 8 thirds. All right, so I'll let you use your calculator. I know you guys, I trust that you can do long division, or you could get common denominators. So we get 4.02083 repeating.
Wait, why isn't it the square root of 65? Or the cube root?
We're using the linear approximation. It's not exactly the same. It's just they're so close that it's, and you can try the cube root of 65. So what if I try the cube root of 65? The actual answer is 4.020725. That's pretty close, right? To 3 decimals, it's the same. That's pretty good. This is all by hand, right? Okay. So if I do the cube root of 61, and I plug it into my linear approximation, so I'm going to plug in 61 in for x to get an approximation. So I do 61 divided by 48 plus 8 thirds. So I get 3.9375. So is that pretty close? We can check. 61 raised to the 1/3 power. 3 points. So the actual is 3.936497, and so on. 3 decimals? Pretty close, right? Well, not really 3. 2.5.
So over.
But it's still pretty close.
Let's see if we get over.
So would these be over or under? So based on the second derivative, if you take the second derivative and plug in 64 into them, you would see that your curve is concave down. Okay, do we know it's concave down just based on the shape of the cube root function? Do you guys all know the cube root function? So it's concave down. So concave down. So that means that these are both overestimates. Which makes sense if you actually look at it, right? It's a little bit over for each of them. All right. So what if I give you a test and I write it in a different way? Does that throw you off? What if I say something like, we'll skip 4. What if I go down to 5? Use a linear approximation to approximate the square root of 145. Hello. So would you guys know how to approximate the square root of 145?
Yes.
Yeah. So I don't phrase it the same way, though. So can you identify what our function is?
Square root of x.
That is, f of x equals the square root of x. All right. Am I using 145 for my x? No, I wanted to pick something that I know how to do. Exactly. Oh, you guys got it. So 144, comma 12 is the point. And you guys all do this in your head. You know that the square root of 145 is close to 12, right? So that's the point we're using. We're using 144, comma 12. So if we did not have a calculator, how would we do this? We would use our calculus. So you would use, yes, guess and check a lot. All right, so we're going to take our f of x equals the square root of x. And we take our derivative. So 1 over 2 root x. We plug in the x value that we can take the square root of. So we plug in 144 to find our slope. Yeah, it's very flat. 1 over 24, I agree. Our slope, our point is 144, comma, 12. So we plug it into our point slope form, and we simplify to get the linear approximation. So we're going to have 1 over 24x minus, Ian, are you ready for it? 144 divided by 24?
6.
Thank you.
I know my 124 is my favorite number.
I know it is.
Human calculus.
I know.
Why?
I don't know.
Hey, you just like 36.
It's
I
a
like
high
36.
quality
It's a
number.
very beautiful
I
number.
like-
Lots of factors. If I had a class of 36, that would be too much to have a class of 36.
Okay.
But if I had a class of 36, think about all the groups that I could have. Groups of 6, groups of 4, groups of 8. Or not 8. 18, 2.
Groups of 1.
What else? 3, 12. Oh, it's so exciting. All right, Emily.
You can do this for any equation, right? It doesn't have to be the square.
Yeah, it can be any equation, yeah.
Isn't that just the same thing as taking the first derivative, though?
Is what the same thing?
Like if you were to do it with another.
Yeah, all of them are going to be like the first derivative to find the slope. Yeah, and so you're just finding the equation of the tangent line. Over and over and over. Same thing every single time. So our linear approximation, 1 over 24x plus 6. So if I'm asked to find the square root of 145, I do 1 over 24 times 145 plus 6. And Grant, you said you have it?
12.0416 repeating.
Okay, good. And if you find the actual answer, if you did the square root of 145 on your calculator, 12.04159, yep. So it's pretty close. Yeah.
Except
You
All right, we
got
good?
a one?
The number following our full calculation.
You got a 1?
12.0416 repeating.
Oh, wait, just kidding.
You got it? Okay. All right, so would you be able to solve questions that look similar?
Probably.
So use the linear approximations to approximate the solutions of x squared equals 123 and x cubed equals 123.
So these two problems in one.
This is 2 problems in 1. So let's talk about the x squared equals 123. I just want you to tell me what function and what point. So let's start with the first one. So x squared equals 123. If I was taking the square root, I'd have plus or minus the square root of 123. So my function would be square root of x. What point would be close to it that I can take the square root of? 121, comma 11, exactly. But if I have the cube root, I would have x equals the cube root of 123. What function would I use for this one?
125.
What function though?
Oh, cube root of x.
Cube root of x in the point, 125, comma 5, exactly. Do you guys understand that? Yeah, so then you would finish that out.
Are we?
So number 7 is one that was an actual AP question a few years ago. So it says the approximate value of f of x equals the square root of 4 plus sine of x at x equals 0.12 can be found by the tangent line approximation using x equals 0. So find the approximation for f of 0.12. So you would just take the derivative, which is a little bit harder, right? Because this is f of x equals 4 plus sine of x to the 1/2. So you'd have 1/2 times 4 plus sine of x to the negative 1/2. Whoops. Yep, times the chain, so cosine of x. You would plug in 0 to find our slope. So you get 1/2. 4 plus 0 is going to be 4 to the negative 1/2 times cosine of 0 is 1. So Alex Pegram, how do I do 4 to the negative 1/2?
4 to the negative 1/2, so you can bring it over. And then
So
you
1
can bring it
over 4 to the 1/2. So it becomes
1/4.
1/4.
it was 1/2 and times another 1/2 gives 1/4, right? So that's our slope.
Hot dogs, hamburgers, Cheetos.
All right. And then we still need the point at 0. So if I go back into my original to find the y value that goes with 0, it'd be the square root of 4 plus sine of 0, which is 0. So square root of 4 is 2. So our point is the point 0, comma 2. Our slope is 1/4. So that's kind of nice because we actually have the point, like the y-intercept, right, our b. So our L of x is going to be approximately y equals mx plus b. So 1/4 x plus 2. So would you be able to find the approximation for f of 0.12? Sure. 1/4 of 0.12 plus 2. So it's 0.03 plus 2, which is 2.03. And that was on the non-calculator portion. Would you be able to do that? Sure. I think you probably can. And then sometimes you might see these as well, like little tables, but we'll skip it. It's fine.